Welcome to the 17th part of the video tutorial series. In the previous video, we looked at the inner join and the left join in SQL. In this video, I'm going to look at the right join and the full outer join. We start with the right join. The right join returns all records from the right table even if there are no matches in the left table. Let's see what we have in the employees table. And also from the orders table. Let's see what we have. We have the ID, first name, last name. Okay. Then the orders table, we also have employees ID. We're going to join these two tables using the right outer join based on the employee ID. We say select all dot orders order ID e dot last name e dot first name from orders as O right join employees as E on orders dot order ID equals E dot employees ID. This one's supposed to be employee ID. Let's check what we have. This is what we have. The right join returns all employees even if they haven't handled any order. If an employee hasn't placed an order, that is the orders.orders ID will be now. Let's check the employees again. You will find that I added another employee here with ID 10 who hasn't done or handled any orders. This one. In the orders, we're not going to find 10 here. That's what I did. So this statement or this query is going to return all employees even if they haven't handled any order. But where is that employee who hasn't handled any order? We can say order by or dot order ID. So if the employee hasn't handled any order, in the order ID it will be now. So let's check. There. This is the employee we added who hasn't handled any order. So since they haven't handled any order, the employee last name and first name they are there, but the ID is now because they haven't handled any order. No wonder it's now here. Let's check the same query using the left outer join. Let's see what we get there. So the left outer join has returned all the orders, including those with no matching employees. If an order has an employee ID that doesn't match any employee ID, last name and first name will be now. But because of the relationship between the employees and the orders is that for an order to happen, you need to have employee ID. So I didn't add any record that would satisfy the left join. I didn't add any order or any ID, order ID, having customer ID, but no employee ID. So the right join will list all employees even those who haven't made any orders. Now to flip the tables, we use the left join, meaning it will return all orders, even those orders with no employee ID, or those orders which haven't been handled by employees or any employee. But in this case, we don't have such orders. So the right join there, we are getting the employee who hasn't handled any order. But the left join, we're not going to get such orders without the employee because of the relationship. For an order to happen, we need an employee. But let's try to experiment if we can add an order without the employee. We want to check the orders. So these are the orders. Then we're going to say insert into orders customer ID, and order needs to have the customer, so customer's ID. Then for the employee, we're going to leave blank. How about ship via? Let's see. Ship via, we're going to add the freight. Let's see. The freight we add. Let's see, just these three. And then we say the values for the customer ID values. We say we're going to use the test one vignette, which is the ID. And then for the employee, we leave it blank. Ship via, which we say 2, this is an ID. And the freight, just say 9. Then we close, let's see what we get. One row affected. Okay. Then the orders. Okay. So it should be the last order, last one. Okay. This one. Okay, so we can have an order without an employee or without an employee ID. Okay. So now let's run this one. That one will get the right join. Now let's run the left join. Okay. Now since this one we are ordering by ID, let's order by employee ID. Let's order by e.employee ID. There. So we are just flipping the tables. This one, the left join, is returning all the orders, even those orders which haven't been handled by any employee. Then this one, the right join, is returning all the employees and their orders they handled, even those orders they didn't handle by any employee. Let's move on to the full outer join. The full outer join returns all records when there is a match in the left table or right table. The full outer join returns all records from the right table. The full outer join returns all records when there is a match in the left table or right table records. Full outer join and full join are the same. If you remember, in the 15th part of the tutorial series, we said the full outer join can potentially return very large results set. Let's join the customers table and the orders table using the full outer join. I'm going to say select C dot customer name or dot order ID from customers, full join or full outer join, they are the same. Full join orders, this one as C as all, then on C dot customer ID equals all dot customer ID. For the customers, I think we have contact name. Contact name, I think. Yeah, this. Let's check. We have performed a full outer join between the customers and the orders table. We have returned all customers even if they haven't made an order. All orders even if the orders customer ID doesn't match any customer. So rows without a match on either side will contain null values in the matching column. Let's see if we order by the name C dot the contact name. Yes, contact name. Let's see what we get. We have ordered these ones. How about the order ID? We say order by all dot order ID. Order ID. In fact, let's also select the ID. This one, that's going to even make more sense. Even here, we do the same. So we go back to the first one. Need a comma here. So we have the customer ID, the contact name, and then the order ID. So this one, we are ordering by contact name, and this one by order ID. Let's use the contact ID, the customer ID. Customer ID. We are ordering by this, okay? And then this one. For this one, we have returned all the customers, even if they haven't made any order. As you can see, they haven't made any order. This customer hasn't made any order. No wonder we had to order by the ID because we wanted the null values to come on top. So we have returned all the customers and all the orders. All the customers who haven't made any order and all the orders made by the customers. This is more like the union of all the tables, the two tables, the orders table and the customers table. Now, let's check this one. Even this one, we have returned all the customers, but it's just the ordering which is different. This one is ordering by customer ID, which is this one. So we have returned all the customers and all the orders, but we are ordering this one. Ordering this one by customer ID, we wanted to see if we have got customers who didn't make any order. Looks like all our customers, they made any orders, but this one, our employees, this one, we returned all employees and all the orders, even those employees who didn't handle any order and those orders that were not handled by any employee. So we are ordering by employee ID, this one. For this one, we wanted to see if we've got customers who didn't make any order. No wonder we are ordering by customer ID. If we add now customer IDs, so this one is giving us the full information which can be helpful to us to check those customers who didn't make any orders and those orders which didn't have or were not made by customers. By ordering using the customer ID, we wanted to see if we've got orders with now IDs. This one, we are checking the customers who didn't make any order and those orders were made by customers. But most importantly, we are checking those customers who didn't have any orders, who didn't make any order. For today, we end here. Don't forget to like the video, share and subscribe to my channel. In the next tutorial, we are going to look at the self-join and the union in SQL. If you have any question, post them in the comment section below. I'll make sure I answer them. Thank you for watching. Let's meet in the next video.